Good morning student. Previous class I discussed some terminology regarding about the chemical thermodynamic. I discussed about the introduction of system, types of system, what is boundary, what is surrounding, and also I discussed some important points regarding about the system. And also I discussed about some thermodynamic process. Now I am going to discuss about exchange of energy. Exchange of energy means the exchange of energy between system and surrounding. Suppose this is your system and the other parts except this system are called surrounding. There are three different ways by which the energy can exchange in between system and the surrounding. These three different ways are: number one is your light, number two is your heat, number three is your work. By the help of these three ways, we can able to transfer the energy from system to surrounding and also from surrounding to system. Basically, the energy can be exchanged between system and surrounding by heat and work. Let me explain about heat and also work. At first, I am going to discuss about heat. Heat is the form of energy exchanged between system and surrounding at different temperature. Suppose a body at a higher temperature and a body at a lower temperature, then the body at a higher temperature transfer heat energy to the body at a lower temperature until thermal equilibrium is established. Until thermal equilibrium is established means the temperature of the body must be equal to the temperature of the another body. Suppose this is your one body, this is your another body. Suppose this body having temperature 40 degrees centigrade and this body having temperature 30 degrees centigrade, then obviously the heat is transferred from this body to this body until thermal equilibrium is maintained. That means when heat is transformed from this body to this body, then the temperature of this body goes on decreases and the temperature of this body goes on increases. After decrease of the temperature of this body and also after increase of the temperature of this body, a equilibrium point will reach at 35 degrees centigrade. At this temperature, both the body having same temperature, that means this body having 35 degrees centigrade, this body having also 35 degrees centigrade. Then there is no flow of the heat from this body to this body because these two bodies attain the thermal equilibrium. So remember, a body at a higher temperature transfer heat energy to the body at a lower temperature until thermal equilibrium is established. Heat is a path function. That means it do not depends upon the initial state and final state of a system. Remember an important point: if heat is absorbed, then the value of Q is written by positive sign. Q indicates the symbol of heat. That means Q is the symbol of heat. Suppose a body absorbs 50 kilojoule heat, that means we can write Q equal to plus 50 kilojoule. Remember an important point, if heat is absorbed, that means the value of Q will be written by the help of plus sign. If heat is released, then the Q value will be written by the help of sign minus. Suppose a body release 100 kilojoule, that means we can write here Q is equal to minus 100 kilojoule. So remember an important point, if Q equal to positive, heat is absorbed. If Q equal to negative, then heat is released or evolved. Next I am going to discuss about work. It is denoted by W. What is the meaning of work? Work is said to be done when a body is displaced by the application of force in the direction of force. That means suppose a body is present here. Suppose some amount of force acting on this body in this direction like this. That means from left to right. Then what will happen? By the help of this force, the body can displace like this. That means the direction of displacement of the body is equal to the direction of applied force on the body. So now I can say that the body doing some work. So remember, work is said to be done when a body is displaced by the application of force in the direction of force. This is the direction of force, this is the direction of displacement of the body. Generally, we can write W equal to F into S, where F is the force, S is the displacement. Generally, we know that W is equal to Fs cos theta. In chemistry, generally we know that the reaction does not depend upon the angle. So here the angle theta equal to 0. So here I can put W equal to Fs into cos 0 degree. We know that cos 0 degree is equal to 1. So here I can write W equal to Fs into 1 equal to Fs. So in case of chemistry, generally we can write W equal to F into S. Remember this formula. By the help of this formula, we can able to do many problems. We can also know that electrical work W equal to E into Q, where E is the potential difference, Q equal to charge. Again we know that Q equal to IT. Here I is the current, T is the time. Now put the value of Q in this equation. Then I can also write electrical work W equal to E into IT. Remember also another formula, work W equal to P into dV. Here W is the work, P is the pressure, dV is the change in volume. We can also write W equal to PdV equal to dnRT. Here R is the universal gas constant, T is the temperature, dN equal to change in number of mole. Remember some important point, work done in isothermal reversible of an ideal gas. Remember an important formula for expansion. We can write W equal to minus 2.303 nRT log of V2 by V1. We can also write W equal to minus 2.303 nRT P1 by P2. Here P1, V1 related to the initial state, P2, V2 related to the final state. That means P1, V1 are the volume and pressure respectively at the initial state. P2, V2 are the pressure and volume respectively at the final state. Remember another formula for compression. W equal to 2.303 nRT log of V2 by V1. Again we can also write W equal to 2.303 nRT log of P1 by P2. Remember the unit of both heat and work. In SI system, the unit of both heat and work is joule. In CGS system, the unit of both heat and work is all. 1 joule equal to 7 or 1 calorie equal to 4.2 joule. 1 liter into 80 am equal to 101.3 joule. Next, I want to do a problem. Calculate the amount of work done when 0.75 mole of an ideal gas expands isothermally and reversibly at 27 degrees centigrade from a volume of 15 liter to 25 liter. From this problem we can write some data. Here V1 equal to 15 liter, V2 equal to 25 liter. Look at that. The volume changes from 15 liter to 25 liter. That means the initial volume, that is V1 equal to 15 liter. The final volume V2 equal to 25 liter. Here temperature is given, so here I can write T equal to 27 degree centigrade, which is equal to 273 plus 27, that is equal to 300 Kelvin. Here N is given, that is 0.75 mole. So here I can write N equal to 0.75 mole. We know that the value of R equal to 8.314 into joule into Kelvin inverse, mole inverse. We know that for isothermal expansion of an ideal gas, W equal to minus 2.303 nRT log of V2 by V1. We know two formula. For expansion, another is for compression. Here a word is written, that is expand. Ideal gas expand isothermally and reversibly. So it is bound to apply this formula. Also another formula is given, that is W is equal to minus 2.303 nRT log of P1 by P2, but we cannot apply this formula because in our question the value of volume is given. That means we can think about V1 and V2. So it is bound to apply this formula. On the other hand, we also know that W equal to 2.303 nRT log of V2 by V1. Also we know that W equal to 2.303 nRT log of P1 by P2. We cannot apply these two formula because here the gas expands, so it is bound to apply the formula which is related to the isothermal expansion of an ideal gas. So according to the question, it is bound to apply this formula. Now put the value of V1, V2, T, N, R in this equation. Then I can write W equal to minus 2.303 into 0.75 into 8.314 into 300 into log of 25 by 15. Imply that I can write W equal to minus 2.303 into 0.75 into 8.314 into 300 into log of 5 by 3. We can divide the 15 by the help of 5, then the quotient is your 3. Here I can also divide the 25 by 5. Here the quotient is your also 5. So here I can write log 5 by 3. Now solve the log 5 by 3. Before solving the log 5 by 3, it is bound to remember some important formula related to the logarithm. Log 2 equal to 0.301, log 3 equal to 0.4771, log 10 equal to 1, log 100 equal to log 10 square equal to 2 log 10 equal to 2 into 1 equal to 2. Similarly, log 1000 equal to log 10 to the power 3 equal to 3, log 10 equal to 3 into 1 equal to 3. Similarly, you can write log 10 to the power 4 equal to 4. Similarly, you can write also log 10 to the power 5 equal to 5. Remember some important formula also. Log x to the power y equal to y log x, log x by y equal to log x minus log y, log xy equal to log x plus log y. Now apply the log x by y equal to log x minus log y here. Then I can write W equal to minus 2.303 into 0.75 into 8.314 into 300 into log 5 minus log 3. Now I can write W equal to minus 2.303 into 0.75 into 8.314 into 300 into log 10 by 2 minus log 3. Now I can write W equal to minus 2.303 into 0.75 into 8.314 into 300 into log 10 minus log 2 minus log 3. Because we know that log x by y equal to log x minus log y. So here I can write log 10 by 2 equal to log 10 minus log 2. Now put the value of log 10, log 2, log 3 here. Then I can write W equal to minus 2.303 into 0.75 into 8.314 into 300 into 1 minus 0.3010 minus 0.4771. After calculation, it is seen that the value of W equal to minus 955.96 joule. Next, I am going to discuss about the internal energy. It is denoted by capital E or also denoted by U. What is the meaning of internal energy? The total energy stored in a system under a given set of conditions is called its internal energy or intrinsic energy. Suppose a system is present. This system is present in a given set of conditions. In that given set of conditions, suppose the amount of energy stored in the system is 25 kilojoule. Then this amount of energy is called internal energy. The internal energy will be the sum of all sorts of energies possessed by various constituents of molecule, such as electronic energy, that is suppose taken as E small e, and also kinetic energy, that is your E K, potential energy, that is your suppose EP, rotational energy, suppose that is taken as ER, nuclear energy, suppose that is taken as EN, vibrational energy, suppose this is taken as EV. There are different types of energy possessed by various constituents of the molecules. So remember, the internal energy U equal to sum of all sorts of energy. So here I can write U equal to EE plus EK plus EP plus ER plus EN plus EB plus etc. Suppose a system having internal energy U1 at the initial state. After applying a thermodynamic process, the state of the system changes at that condition. Suppose U2 is the internal energy. That means U1 is the internal energy of the system at initial state. U2 is the internal energy of the system at final state. By the help of internal energy U1 and U2, we can able to find out the change in internal energy. The change in internal energy is denoted by del U. The value of del U equal to U2 minus U1. Suppose I want to think about a reaction. Suppose the reactant converted into product. This reaction suppose takes place in a system. In this system, the internal energy of the reactant is denoted by UR. The internal energy of the product is denoted by UP. Here UR is the internal energy at the initial state. UP is the internal energy at the final state. But UR corresponds to the internal energy of the reactant. UP corresponds to the internal energy of the product. In this case, we can write the change in internal energy del U equal to UP minus UR. Remember these two relations. If U2 greater than U1 or UP greater than UR, then del U equal to positive, because this is a greater than this. That means we know that greater integer minus smaller integer gives the positive value. So remember, if U2 greater than U1 or UP greater than UR, then del U equal to positive. Similarly, remember, if U2 smaller than U1 smaller than ur, then del u equal to negative. Next, let me explain about the characteristics of internal energy. Internal energy is a state function. That means the value of internal energy depends upon the initial state and final state of a system. Next point, internal energy is an extensive property. That means the value of internal energy changes with the change of the amount of substance. Next point, since it is a state function, it do not depend upon the path followed. Next point, the absolute value of u cannot be calculated. Next point, what the change in internal energy del u can be calculated. Next point, for cyclic process del u equal to 0. Internal energy has exact differential. That means I can take the integration of du from u1 to u2. We can write u2 minus u1 equal to del u. These are some characteristics of internal energy. Next, I will discuss about the first law of thermodynamics. The first law of thermodynamics is also called law of conservation of energy. What will be the statement of law of conservation of energy? It states that the energy neither be created nor be destroyed, although it may be changed from one form to another. Suppose take an example. This is your turbine. The water falls on the turbine like this. The water comes from the river. Then what will happen? The turbine will start rotate and produce the electrical energy. That means here the kinetic energy converted into rotational energy, then the rotational energy converted into electrical energy, then the electrical energy can be converted into mechanical energy, then the mechanical energy is converted into any other form of the energy. From this example, it is clear that the energy can neither be created nor destroyed, although it may be changed from one form to another. Next, I want to explain about the explanation. Let del u equal to change in internal energy, Q equal to heat, W equal to work done. Then according to the first law of thermodynamics, del U equal to Q plus W. This is the mathematical expression for the first law of thermodynamics. There are many special cases for first law of thermodynamics. Remember some important signs. If heat is absorbed, then Q is written by the help of positive sign. If heat is released, then the value of Q will be written by the help of negative sign. It is already discussed in the heat concept. Similarly, remember another important point: if work is done by the system, then the value of W is written by the help of negative. If work is done on the system, then the value of W is written by the help of positive sign. Remember the important points. If heat is absorbed, then Q will be written by the help of positive sign. If heat is released, then the value of Q will be written by the help of negative sign. If work is done by the system, then the value of W will be written by the help of negative sign. If work is done on the system, then the value of W will be written by the help of positive sign. Now I want to explain about the special cases of first law of thermodynamics. Point 1: if heat is absorbed and work is done by the system, then I can write del U equal to plus Q minus W. We know that heat is absorbed means Q must be written by the help of plus sign. Look at that here, plus Q is written. If work is done by the system, then the value of W is written by negative sign. So here is bound to write minus W. That means we can write simply del U equal to Q minus W. Take another special case: if heat is absorbed and work is done on the system, then I can write del U equal to plus Q plus W. That means I can write Q plus W. Because we know that work is done on the system means it is bound to write plus W. Heat is absorbed, then it is bound to write plus Q. So we can write del U equal to Q plus W. Similarly, remember if heat is released and work is done by the system, then I can write del U equal to minus Q minus W. Similarly, remember if heat is released and work is done on the system, then I can write del U equal to minus Q plus W. These are the special cases of first law of thermodynamics. Next, I want to explain about the limitation of first law of thermodynamics. First point, it puts no restriction on the direction of flow of heat. Second point, it is silent about the feasibility of a process. Next point, it does not tell that heat is a typical form of energy which cannot be completely converted into work. That means 100% energy cannot be converted into 100% work. There is some loss of energy takes place. These are the limitation of first law of thermodynamics. Next, I want to do some problem related to the first law of thermodynamics. a system absorbs 100 joule of heat and performs works of 50 joule. Calculate the change in internal energy of the system. In this question, Q is given, that is your 100 joule. W is also given, that is your 50 joule. There are two ways to solve such type of problem. First way, change the formula and follow the special cases of first law of thermodynamics. Second way, change the value of Q and W by taking the proper sign and use the main formula of first law of thermodynamics. Look at that, here the system absorbs heat. That means see, here the value of Q must be written by using positive sign. So here I can write Q equal to plus 100 joule. In case of plus sign, you cannot also use the plus sign in front of the 100 joule. Simply you can also write 100 joule. Similarly, think that here the system performs work. That means the work is done by the system. We know that when work is done by the system, then the value of W is written by the help of negative sign. So here I can write W equal to minus 50 joule. According to first law of thermodynamics, I can write del U equal to Q plus W. Now put the value of Q and W in this equation. Then I can write del U equal to 100 minus 50. That means here I can write del U equal to 50 joule. In our question, calculate the change in internal energy of the system. So here I can write change in internal energy equal to 50 joule. Next I want to do another problem. 70 kilojoule of work is done on the system and 20 kilojoule of heat is given out. Calculate the change in internal energy. In this problem, W is given, W equal to 70 kilojoule. Q is also given, that is your 20 kilojoule. Look at that, your work is done on the system. We know that when work is done on the system, then the value of W is written by the help of positive sign. That means here I can write W equal to plus 70 kilojoule. Here also I can write W equal to 70 kilojoule. Look at that, here 20 kilojoule of heat is given out. That means the system releases some energies. We know that when a system releases energy, then the value of Q is written by the help of negative sign. That means here I can write Q equal to minus 20 kilojoule. We know that del U equal to Q plus W. Now put the value of Q and W in this equation. Then I can write del U equal to minus 20 kilojoule plus 70 kilojoule. That means here I can write del U equal to 50 kilojoule. In our question, calculate the change in internal energy. So here I can write change in internal energy equal to 50 kilojoule. Now I want to do another problem. What is the work done by the system if a system absorbs 285 joule of heat with 85 joule of change in internal energy. Here del U is given, that is 85 joule. Your Q is given, that is 285 joule. Look at that. If a system absorbs 285 joule, that means this sentence clearly indicates that the system absorbs energy. We know that when a system absorbs energy, then the value of Q must be written by the help of positive sign. That means here I can write Q equal to 285 joule. Our aim to find out the value of W. We know that del U equal to Q plus W. Now put the value of del U Q in this equation. Then I can write 85 equal to 285 plus W. That means here I can write W equal to 85 minus 285, which is equal to minus 200 joule. This negative sign indicates that the work is done by the system, which is already written in the question. So here I can write the work done by the system equal to 200 joule. Don't write the negative sign. Negative sign only indicate the work is done by the system, which is already written in the sentence. So it is not necessary to write the negative